Last section of this week. I was about to say for the semester, but actually we've got a lot more to go. Not a lot more to go. I'm thinking my other class. My other class, they already finished their sections, but you guys have maybe about 4 more. We're doing this one. This is number 5, and then 11.6, 11.7. So actually 3 more, including today. It's not very many left. What was I trying to do? Oh, I was trying to open Desert. Okay, so let me just talk real quick about today. 11.5. This is the lesson for Thursday. We're talking about annuities. I'm not going to pretend like I'm a financial expert. I'm really not. But what I do know is just a bit of the math. The whole point of this whole chapter is for you to get a kind of a grasp of, I guess, like the scale of the mathematics behind a lot of the financial stuff that you see. So annuities, I think one of the best annuities you may have heard about is the Roth IRA. Or maybe you haven't heard about it. IRA part actually stands for Individual Retirement Annuity. So what is an annuity? An annuity is just when you deposit a certain amount of money periodically, and that interest is gonna grow on top of that. So like, in the previous section when we talked about compound and interest, in that case we only deposited one time, right? So we deposit once and then the thing grows. In an annuity, you're depositing over and over again. The thing about a Roth IRA, which is like a type of retirement annuity, like I said, that one is really good because you have tax benefits, so that you basically are not taxed on it. So a lot of times, if you're setting up some kind of a retirement fund or something, whatever it is, the interest that it gains is taxable. But with a Roth IRA, then that one's not. Anyway, that's just a side note for free. But that's like a real world application where you would see an annuity. Okay, so let's look at the definitions. First of all, an annuity is a sequence of payments made into an interest-bearing account. An ordinary annuity is when the frequency of payments is the same as the frequency of compounding. These are the 2 formulas for the section, although really they're the same formula. So really just one formula. And then if we take this formula, we rearrange it for a different variable, then we'll get the second one. What else do I want to say about this? Let's see. Yeah, so we're talking only about ordinary annuities. So the frequency of payments, how many times you deposit, is the same as the frequency of compounding. That just makes the calculation easier. It's going to make things nicer. We have less variables to worry about. Okay, let's talk though quickly about these formulas here. So let me just zoom in on this guy. A is equal to m times 1 plus r over n to the nt minus 1 over r over n. All these letters, they mean basically the same things that they used to mean, except now the new one is m, right? Well, m is sort of like the p value in the compound interest formula, except this time the m is, you think of it as the multiple payments. So maybe m for multiple payments. It's the number, it's a periodic payment amount, we call it. So it's kind of the thing that you're going to pay every time at every period. And the way I usually think about it is it's sort of like a monthly payment. Now, I say sort of because it's possible that the period is not monthly. It could be yearly, in which case it would be the yearly payment. It could be semi-annually, which means it's twice a year. It could be, I don't know, every quarter, so it'd be like 4 times a year. So M could be 4 in that case. I'm sorry, not M wouldn't be 4. M would be the amount that you pay every quarter. But basically, you think of it like the payment, the dollar amount that you're paying down at each interval. Okay, so that's M. Well, I don't know why I just erased that. That's the periodic payment amount. Okay, what else do we have? We have R. R is the same thing it always meant. It's still the rate as a decimal. And what else do we have? We have a T in there. Oh, we have an N in there first. N is just the number of times compounded in 1 year. So same like it was before, right? R and N is the same as in the previous sections that we've seen. And then we have T. T is also the same as before. It's the number of years. All right, so looking at the formula, there are a couple of things that you have to be very careful for when you're plugging into a calculator. Make sure that you have at minimum these number of parentheses, but in fact, when you plug it in, I recommend even more because you want your denominator to be separated by its own set of parentheses. If not, what happens is you're going to divide by r and then divide by n. So like, I'll show you what I mean. Let's say I'm doing some calculation. I have a is equal to blah, 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 and I stick in my m. I type it in like this, parentheses for these brackets, right? And then 1 plus r over n to the, in parentheses for the, oh, I'm sorry. I want to do like this. One parentheses for the big brackets, right? And another parentheses for my numerator, 1 plus r over n to the, in parentheses, nt, that's my exponent, right? Remember, exponent's always in parentheses, minus 1. Okay, at this stage, if I was to just hit divide, I have an error because I have this numerator here, right? I got to close off my numerator. So here's the numerator, this bracket with this bracket, and then divide by r over n. Now, if I write it like this, what happens is following the order of operations, it's going to divide by r and then divide by n, but that's not what I want. I want to divide by r divided by n. So you have to keep the denominator in parentheses, in other words. Now, you know, I said there's a bracket, but actually I took away the bracket and I used this parentheses here is actually already the numerator parentheses. So really I would have needed one more set of parentheses if I wanted to look right. But as I had it written, the m would have been multiplied to the front anyway. So it's actually not super important that that's there. Okay, in any case, this is how you would type something into your calculator. I know it looks kind of confusing, but it's just because the order of operations is critical, right? If you don't tell the calculator the proper order of operations, it's just gonna follow the standard PEMDAS or whatever. It's gonna follow the standard order of operations. So it's gonna say multiplication comes before addition, exponents comes before multiplication, etc. So we have to specify the parentheses to make sure that we keep the numerator separate from the denominator, and any other order of operations is followed accurately. That's, I think, the biggest challenge for this section. Otherwise, it's pretty simple. What you should be aware of is make sure that you understand when to apply these formulas, because later on, like I said, we're going to start seeing multiple types of problems and we have to distinguish which formula applies. So the keys, I think, here are, if you're talking about an annuity, there's multiple payments as opposed to a single payment, and there's compounded interest. Okay, guys, let's just jump straight into the questions now. Actually, no, let's pause. I'm going to pause for the introduction video, and then let's jump into the questions in the next video.